Okay, I'm going to solve the satellite problem that we had in class. Here's the diagram. We had two tracking stations, A and B, each spotting a satellite, and they gave you the angle of elevation from each station. And the ultimate goal in part B here was to find the height of the satellite, or in other words, if I drew a perpendicular line down here, just like with the mountain problem that we did in class, we wanted to find the height. But notice that that height is inside of a right triangle, which I'm going to draw here in green. And in that right triangle, I know it's a 90 and 87, I could find the third angle, but I don't know any of the sides. So that's not enough information to find the height. So what I'm going to look at to find that is this purple triangle over here that goes between station A and station B. And the purple triangle and the green triangle both have one side in common, and I'm going to call that X. And actually in part A of this question, it asks you to find the distance of the satellite from station A, which would be A to the satellite, that distance X there. So that's what we need to find first. So what I'm going to do is blow up a picture of this purple triangle. And so far what we know is that this is 84.2 degrees. And oh, it also told us that A and B are 50 miles apart. So this was B and A. So that's 50 right there. Now, as of right now, it doesn't look like enough information, but remember they also told us that this angle outside is 87 degrees. And since that's on a straight line, then this angle and this interior angle here have to add up to 180. So if I do 180 minus 87, I get 93. And 93 then would be the second angle inside this triangle. So I have 84.2 degrees, and then this one's 93 degrees, and so now I can find the third one. So I do 180 minus the 84.2 and minus the 93, and I get 2.8 degrees. So up at the top here is 2.8 degrees, and I'm looking for X, which is this side of the triangle. So notice here that I have all three angles and just one side, so that's probably going to be a law of sines problem, because I have at least one side and one angle that are across from each other. So I'm going to say, all right, I know that the 50 is across from the 2.8, so sine of 2.8 degrees divided by 50 equals, and if I want to find X, I have to use the angle across from it, which is the 84.2. So sine of 84.2 degrees over X. Then to solve that, I cross multiply, so that's 50 times sine of 84.2 equals X times the sine of 2.8. And so to get X by itself, I just divide by the sine of 2.8. Divide by sine of 2.8. And in my calculator, I do 50 sine 84.2, close my parentheses, divided by sine of 2.8. And I get X equals 1018.306. So 1018, whatever the units here are, miles. So 1018.306 miles is the distance from station A to the satellite. All right, and so then part B of the question asked us to find the height of the satellite. So that's in the green triangle here, so what I'm going to do is redraw the green triangle. Remember that we knew this angle was 87. This is my right angle. I want to find the height, and what we just found was that this X here was 1018.306. And now I want to find the height. So because it's a right triangle, I don't have to do law of sines or law of cosines. I could, but I don't have to. What I can do instead, which is easier, is just say, well, in a right triangle, we can always use our regular trig ratios, or our SOHCAHTOA. And notice here, my 87, the H is opposite the 87. And the X distance that I just found is the hypotenuse of this triangle. So I have opposite over hypotenuse would be sine. So what I'm going to do is just set it up in my right triangle. I say sine of, and you always put the angle, so that would be 87 degrees, equals the opposite side, which was my height, over the hypotenuse, which was 1018.306. Oops. And so to find h, all I have to do, this is since h is divided by 1018, I just multiply by 1018.306. That'll cancel, times 1018.306. And so to find height in my calculator, 1018.306 times the sine of, what was it, 87 degrees. And I get 1016.910. So my height is 1016.910 miles. And of course, if I want to check if either of these make sense, we'll notice first of all in the word problem, a satellite should be pretty far away from a tracking station, so it does make sense that it's as big as 1,000. Also, since that 50 is across from a 2.8, that should be really small compared to my x distance here, which is across from an 84. And then when I get to the second triangle, across from 90 degrees was 1018. 87 is a little bit less, so across from the 87 was slightly less, 1016.9 miles. And I'm finished.